Let's see. We are on inverse and joint variation.
Okay. Let me make it real simple. Well, yeah, you're actually on direct, inverse, and joint. Those are the three different kinds you can have.
Okay.
That means that. In other words, if y goes up, x goes up. Or I should say that the other way around. If x goes up, y goes up. If x goes down, y goes down.
Okay.
Inverse, okay, the denominator is x. And you can see that as x goes up, y goes down. And as x goes down, y goes up. So this one might look like that. This one's going to look like that.
Okay.
And joint is just like direct, only there's another variable. Okay?
Okay.
So, give me some specific problems, and let's talk about each of these.
Okay, so this is the day I missed, so I wasn't there for this lesson. So this is all new to me, so.
Okay.
X, y equals 10. Like x times y equals 10.
Okay.
Yeah.
So let's put that in the form of one of these three. So if you were solving for y, what would y be?
Y would be 10 divided by x.
Okay, which form is that? Direct, inverse, or joint?
That is inverse.
And k is 10.
Yes.
Okay?
Oh, okay, that's pretty easy.
It is actually pretty easy. They'll give you some word problems, which can be a little difficult, but let's get the basics down. What's the next one you got?
X, y equals 1/10.
Same thing. Notice that whenever you have x times y, the x is going to end up being in the denominator. Right there. The only difference is this has a different k.
All right.
Okay? And that's the way all of these problems are. There's a lot of relationships that are joint, direct, inverse. The only difference is k.
Okay.
So the difficulty in most of these word problems is solving for k. That's the first thing you have to do. Now, in the problems you've given me so far, you've given me k. All we're doing is solving for y. What else you got in terms of those kind of problems?
Y equals x minus 1.
Is that direct, inverse, or joint? It's direct. In other words, it's of this form. The difference is that the blue looks like this. Here, I should have drawn it in blue. The blue looks like that. That's y equal kx. This one, everything is moved down 1. In other words, that's a translation. So this right here is this line, but it is still of the form of a direct relationship. In other words, when x goes up, y goes up. When x goes down, y goes down. Notice how that's different. In the inverse relationship, when x goes up, y goes down. If I have y equal 2 over x, if I increase x, y gets smaller.
Okay.
If I decrease x, y gets bigger. So that's the primary difference you have to pay attention to. Is the slope positive or is the slope negative? If it's a direct relationship, the slope is positive. Even if you have this -1, still a positive slope. Whereas if I'm plotting the second one, that's going to be a negative slope. In other words, if I'm plotting, say, y equals 10 over x, well, that is hyperbolic in nature, actually, and it looks something like that. But you can see that with that, as x goes to the right, y gets smaller.
Right.
And that's the key thing. Now, this third one here involves 3 variables, y, x, and z, but it's basically saying the same thing as direct. In other words, if I increase x, y is going to go up. Or if I increase z, y is going to go up. If I decrease x, y is going to go down. If I decrease z, y is going to go down. So those are your possibilities, and those are the only ones. You have any word problems? That's usually what they give you here. In other words, they'll give you a direct relationship. They'll say gravitational force is inversely related to the distance between the two objects. And that is true. Gravitational force is inversely, I should have said that, related to the distance between the two objects.
Okay.
In other words, if you have two planets and they're close together, the gravitational force is going to be high. But the further they get apart, not only does the gravitational force get less, but it gets less by the square of their distance, which means it gets less really rapidly.
Right.
Best way you can understand this if you have some problems. Word problems.
Right. Okay, yeah, I found one. It's a little long, but
it's all right. Go ahead.
All right. The luminosity of Polaris is 10,000 times the luminosity of the sun. And then the surface temperature of Polaris is about 5,800 kelvins.
Okay.
And then it says using K equals 33,640,000. Find how the diameter of Polaris compares to the diameter of the sun.
Okay. So what we know is that the surface temperature is directly related to the temperature. Hold on. Let me think for a second. Jesus, they could have given you an easier one than this one.
Right.
This is like jumping to calculus as your first step. They don't make statements like directly related or inversely related or anything like that?
Yeah, but this is more like the one that they do have it's like a paragraph.
Well, if you want to, you're going to have to read the whole thing to me. Because the way they started out is very important. They basically tell you how to write the equation. They will say the luminosity of Polaris is directly related to the diameter, of Polaris? Something like that?
I found one like that. You want me to send you a picture? It's pretty long.
Yeah, go ahead and send me a picture. That's the best way to proceed.
Okay.
You have my email?
Do you want me to just text it to you?
No, because that goes to my phone. I'm on my computer. Here, send it to this email. And that way I can bring it up on my screen immediately.
Okay.
Always send whatever materials you have to this email.
All right.
And make sure you spell it Cowan.
All right.
And that's a good thing to do at least once, because once you do it once, it's easy to do it another time. It's stored in your phone. Are you sending it on an iPhone or
I have a Samsung.
Samsung? Better. On an iPhone, you'd have to attach it as a large image file. On Samsung, just share that picture with this email address.
All right. Let's see.
Make sure you take it horizontally.
Yeah.
Been having some trouble with JPG files. They won't let me rotate it anymore for some reason, so make sure it's oriented the same way you see my email address.
All right.
And then holler when it says file sent.
All right.
Because there's no point in me checking for it until it says file sent on your end.
All right.
And most of these word problems they give you, they're going to give you enough information that you can lay out the formula, everything but K. And then you calculate K. And then they give you, okay, so what if Y was this and X was this? Then you go back and you use the K you calculated. So that's always the first step, is to calculate K.
All right. It's taking a while to send.
Well, make sure there's only one picture with it.
Yeah.
Don't send multiple attachments because it takes exponentially longer to send. I noticed everything was slow. I had to reboot my computer right before I called you, and it took forever. And then it took forever for me to get on the internet. So I'm not sure what's going on, but the internet could be slow. Do you use Comcast or CenturyLink for your internet?
Oh, we have Comcast.
Well, that should be faster. That's what I have. I tried CenturyLink for a while, and it was really slow.
Yeah, we had that too.
So you got my email address okay? Can I close this out?
Yeah.
Just let me check my email here. See if it's come in. Not yet. Does it say file sent on your end? Tell you what, read the problem to me.
All right.
From start to finish.
Okay. The intensity of I of a sound, and then in brackets, I don't know. Yeah. In watts per square meter. And then it varies inversely.
Hold on.
Okay.
Okay, varies inversely means this. With what?
With the square of the distance in meters.
There you go. There's your equation. Now, you don't really need the units. It's nice to have them just to make sure everything checks, but they don't have anything to do with the math as long as the units are all the same. So you could say the intensity is inversely related to distance and to the square of distance. And if you think about it, that makes a lot of sense, right? If you get right up next to a light bulb, it's really bright. But if you get further away, it gets dimmer. Right. And it actually gets dimmer by the square of the distance. In other words, the distance, if you go from 1 feet to 2 feet, the luminosity actually drops by a factor of 4, not double, because it's varying by the square of the distance. Okay, now, so that's the equation, and they're going to give us an I, and they're going to give us a D, and that's going to allow us to calculate K. So what's next in the problem?
Okay. At a distance of 1 meter from the stage, the intensity of the sound at a rock concert is about 10 watts per square meter.
All right, that's all we need. So they're telling us that 10 is equal to K over 1, right?
Yeah.
Distance is 1 meter. The luminosity is 10. Well, that lets us solve for K. What's K?
K is...
Solve that for K.
Is it 10?
Uh-huh. So now we have the specific equation for this light bulb. There it is, right there. Now that's not for all light bulbs or for all things like this. That is just for this specific luminosity and distance. Okay. Now they're going to say, okay, so what's the luminosity if it's at a distance of 3 meters or something like that? What's the rest of the problem? Okay, it says write an equation, and then if you are sitting 15 meters back from the stage, what is the intensity of the sound you hear? Okay, so now intensity, K doesn't change, not for this model, 15 meters squared. Well, that's 10 over 225. So the intensity of the sound when you were 1 meter away was 10. The intensity of the sound when you're 15 meters away is barely a 20th. In other words, you lose a lot. Yeah. That's why everybody likes to be stage side on rock concerts. It's because you get that high intensity sound. The further back you go, it doesn't drop linearly. It drops by the square of the distance. In other words, this dropped by a tremendous amount. You could call that decibels for intensity. Well, that would be 10 decibels. This would be 10 over 225 decibels. So you lose a lot as you back away. But this is what the verbiage says. In other words, because they said the intensity varies inversely by the square of the distance. That means the distance is going to be in the denominator because of the word inverse. Okay. Now, once you have that, then they give you enough information to solve for K. And once you have K, you have the specific. This is the general equation. This is the specific equation over on the right. for this particular model.
Right.
You had different amplifiers, it might make a difference. Or if you had smoke in the room, it might make a difference. Or if there was furniture instead of wood, it might make a difference. But for this particular model, they're telling you K is 10. Have anything else similar to this? These are important because these are what you're going to get asked on the test.
Yeah, I've got one that varies jointly.
Okay. Tell me what. Read the sentence first. What varies jointly with what?
So the work in joules done when lifting an object varies jointly with the mass in kilograms of the object and the height in meters.
All right. There's your three variables. Work, mass, and height. Tell me the general equation based on the words of that first sentence. Read it again.
The work in joules done when lifting an object varies jointly with the mass of the object.
Okay, stop right there. You always know there's a K.
Right.
So you can write that much. Now, the question is, does the mass and the height go in the numerator, or does any of it go in the denominator? Varies jointly.
It goes...
Both of them go in the numerator.
Right, yeah.
Okay? It's only if they say inverse that one of them goes in the denominator. And there is always a K. So the moment you say it varies, I can write K. It's just a question of where the other two variables go. Do they go in the numerator or the denominator? So this is our general equation. Now they're going to give you enough information that's going to let us solve for K. What's the rest of it say?
Okay, so the work done when a 120 kilogram object is lifted 1.8 meters is 2,116.8 joules.
Okay. See what I did? I listed the work. I listed the mass, 120, and I listed the height. The only thing missing is K. You have a calculator in front of you?
Yes.
What's K?
Let's see, one. I got 9.8.
Good. So what is the specific equation for this?
Well,
let's write that in blue.
Is it W equals 9.8 mH?
Yep. In other words, same exact process it always will be. They're going to give you three variables, and that allows you to calculate K. Okay, which we did. And that gives us the specific. Now they're going to ask you another question. What's the rest of the question?
Write an equation that relates W, M, and H. And then...
That's in blue. That's what we've done.
And then how much work is done when lifting a 100 kilogram object 1.5 meters?
How much work is done? K doesn't change. What's the weight or the mass?
100 kilograms.
And the height?
1.5 meters.
Put that in your calculator, and that's the work done.
1,470.
Now, units. Units are, they only complicate the issue. They don't make it easy.
Yeah.
If you assume that they're not going to mess with you by giving you something in foot-pounds and the other in meters. That's messing with you if they mix up your units. But I think it's safe to say that at this level, they're not ever going to do that to you.
Okay, cool.
So you can ignore units. Notice that I don't have units anywhere on here. The original problem said the work done in what? Joules?
Yeah.
That's your answer then. In other words, this is 1,470 joules. Just assume that. And you can always assume that the units are just going to match out. I mean, unless you have a really evil teacher who would give you, well, work can be measured in joules, which is the European system. It's based on meters. Or work can be measured in foot-pounds, where instead of mass, it's weight. So if you have a 100-pound object that you want to move 10 feet, the work done is 1,000 foot-pounds.
Okay.
So I would say at this point, you don't need to worry about the units. And as long as they give you the units like they did, they told you it was in joules, the amount of work done, well, then you know that when you come up with your final answer of the amount of work done, it's going to be in joules.
Okay, sweet.
Okay. Jake, that's the end of the half hour here, so I will let you go.
Right.
Let's see. Before I do, let me just look at some things here. This email address I have here, crickfin4, is that you or is that your parents or?
That's my mom's.
That's your mom? Okay.
Yeah.
What I'm going to do is send your mom an invoice. Last week's session was free. This week's session is not. And so I'll send her an invoice and she can choose to figure out how she wants to pay it. If she wants to pay it with PayPal, that's fine. If she wants to send me a check, that's fine. She'll have, she'll have both options. But if she has PayPal, that's a lot easier for her to do.
Okay, cool.
Okay. And I noticed that her note last time indicated that you wanted a regular time. I can do that if you like. In other words, I can give you the 6:30 time slot every Monday night. Except next week. Next week, I cannot do it.
Do you have any earlier, or can you not do it at all?
Hold on one second.
Okay.
Vicky? Hi. Listen, can you hold on for 1 minute? I'm just finishing up a tutoring session. Okay, sounds good. Bye-bye.
Later next week.
Yeah, I have a 6:30 that already scheduled for next Monday. I can do before or after if you like.
Okay, before works good.
Okay, let's go ahead and put you in there. At 6.
Okay, perfect.
Oops, hold on a second before I let you go. And now, would you like me to try to lock that time up on Mondays? I'm not going to be able to do it on the 25th. But most every Monday I can do that.
Okay, perfect.
You want me to do it?
Yeah, sure.
And you want 6 o'clock?
Yeah, 6 works good.
Okay. The only time we're going to have to work with is on the Monday of the 25th. And then we'll have to either do later or earlier or something.
All right.
Okay. All right, Jake, I will talk to you next Monday night at 6. Actually, I'll just text you the meeting ID number.
Right. Okay. Thank you.
All right. You're welcome. Bye-bye.
Bye.